Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, today we are starting a new sums of AFD, SFD and BMD problem number 3. In problem number 3 we are taking a type as internal hinge type of problem. Let's see what the internal hinge will do in the AFD, SFD and BMD. Let's see. See friends, this is your internal hinge. In this types of, why we are, as you all knows, where is given over internal hinge, because in fixed, as you all knows, the reaction will be 3, fx equal to 0, fy equal to 0 and moment also equal to 0. So in that way this, well, and this ruler is also there, so total number of reaction will be 4. Then it will be indeterminate structure. To determine the structure we are given the internal hinge. And what is internal hinge? As you all knows, the internal hinge, we are providing internal hinge because of to determine the structure. Now solution. Now let's see the solution. See, this is unknown, this is your VA part and this is your H part, and take a moment, one moment, this is your moment MA, and this is your also unknown, this is V at C. Okay, now we got all the value, we know all the values first. Now how you know the value first? Find out the support reaction calculation. Okay, now let's start with the solution. Our first one will be support reaction calculation. First we have to calculate the reactions. Okay, now what we have to do, since B is an internal hinge, a bending moment at B will be 0. As you all know, in internal hinge bending moment will be 0 always. Okay, now considering BEFC part. Okay, now already considering BEFC part, now bending moment at B is equal to 0 gives, bending moment gives, see, bending moment will be gives, see, this plus VC into this distance minus 8 into this distance minus 5 into this distance. Okay, VC into 5 see, this is, follow the sign convention like this is the sign convention. Okay, see, this VC will go from section, this will go like this. See, this is positive and this will go like this, so these both are negative. 8 into this distance 2, 5 into 4, sorry, minus 8 into 2 minus 5 into 4 plus VC into 5. Okay, now while solving this you get the value of VC. Your VC value will be 7.2 kilonewton. Okay, 7.2 kilonewton upward. Now applied over here, 7.2 kilonewton. Okay, this is come your VC part. Now summation Fy equal to 0. Now after that we have to apply summation Fy equal to 0 upward positive. Okay, upward positive means what the value will come? See, this VA will come, VA minus 8 minus 5 plus 7.2 is equal to 0. Now VA value will be, while solving this, VA will be 5.8 kilonewton upward. Okay, 5.8 kilonewton. Now apply, write it over here, 5.8 kilonewton upward. Now what about H? While finding the H, we take the summation Fx equal to 0. Now let's see, summation Fx equal to 0, this as positive. Okay, now X, see, this will go this direction, so this is minus, this is plus, and UDL will be positive. Always remember this UDL also will come in the picture. Okay, not neglect the UDL part. Okay, because this will also in X direction. Okay, now see, minus HA plus 10 plus UDL will be 5 and load distance will be 4, then 5 into 4, 5 into 4, okay, 5 into 4 equal to 0. While solving this, you get the value of HA, value will be 30 kilonewton. Okay, our direction will be correct. Now apply over here 30 kilonewton. After that, now see, assuming an anti-clockwise resisting moment MA at A as shown. See, we all knows X will done, Y will done. Now that moment will also come in the picture. So we take the moment at anti-clockwise first. We don't know the direction, so we are taking anti-clockwise. Then written over here. Then consider part BA. Now consider part BA. Then consider part BA bending moment at A. Now what will come bending moment at A? Bending moment at A. Bending moment at B. What is bending moment at B is equal to 0. So what will come in the picture? See, minus MA, because see, if you are like this, put a rod over here. See, this section, this side is going downward. This follow this sign convention. This follow this sign convention. So that's why minus MA. After that, see, this UDL will also go minus 5 into 4 into 4 by 2. Minus 5 into 4 into 4 by 2. Okay, see, minus 5 into 4 into 4 by 2. Now this minus 10 into 2, minus 10 into 2, 10 into 2. After that, this 30 will be go plus 30 into 4, this distance, plus 30 into 4 equal to 0. While solving this, you get the value of MA. Your MA will be 60 kilonewton meter. Now write it over here. Okay, after that, see, answer for MA comes out to be positive. So assumption of direction of MA is correct. We are assume this direction is correct. Okay, that's why we got the value positive. After that, we have done with the support reactions. Now we have to resolve the part. Over here. See, now we have to resolve the part AB, then BC. Okay, let's see the first part. Now draw the diagram first. Okay, now see, now we have to see the part B. This is your A, this is your B. Now we have to see the part A and balance part B. Now how will you balance? See, this 5.8 coming from this to C, that's why this will come 5.8. Okay, now see, this 30 going this side and 10 will go this side and plus, and this also going 5 kilonewton, 2 meter and D. This is also 5 fours are 20. Then 20 go this side. 20 plus 10, 30. 30 will go this side. 30 will go this side. So that's why it will balance. This value will be get 0. Okay, because this will balance over here only. Now draw the AFD, SFD and BMD. Let's extend first. Now first draw the SFD part, sorry, AFD part. This is your A, this is your B. Okay, now see, this is going compression. Compression means minus goes to inside, so compression is nothing but minus, it will go inside 5.8. this is compression, so draw over here inside the frame, minus will be inside the frame. Okay, compression, this is AFD. After that SFD. Now see the calculation of SFD over here. Shear force calculation, follow this sign convention. Okay, shear force A is equal to 30 kilonewton, shear force D below see shear force shear force A at left equal to 0, and shear force A at above, just above, below is 0 and above is 10. See, this sign conversion is following. Okay, now at D when we are taking section over here, this will also come 30. Okay, now we are taking below, see this 30 plus this UDL also come. See this 30 plus 5 into 2, 10 will come over here. This is nothing but 5 into 2. Okay, this is equal to 20 kilonewton. In D just above, see plus 20, then this 10 minus 10 is 10. See, this is shear force, this above what will come first, this 30, then minus 10, we are direct written over here this 20. Okay, and this 10 will become over here this. Okay, now this 10 will come, this one is that 10 kilonewton. Shear force B is equal to 0 because in this there is no load. Now draw the diagram first. See, at A is 30 kilonewton, so 30 will become something over here. After that this will come 20 D, 20 will be here, something 20 will here, and after that in D also there is 10, this will come over here. Now see, in UDL shear force will be inclined straight line, as you all know. In B that will be 0. This is your 30, 20, 10. This is positive, that's why away from the, this is positive. Okay, now this is your A part, this is your D part, this is your B part. Now bending moment diagram. Now bending moment diagram, this is your A part, D part and B part. Now see, now take bending moment calculation, write it over here. Bending moment calculation, follow the sign convention. Okay, now bending moment at A is equal to minus 60 kilonewton meter. Trying to bend A inside 60 kilonewton meter. See, this is a diagram. You are taking bending moment at A, but A you can take this whole part or this part. So this one has also have this value. See this 60 section, this size is going downward, so that's why it will come minus 60. After that bending moment at D equal to, and what about D? Bending moment at D is nothing but minus 60 plus 30 into 2 minus 5 into 2 into 2 by 2. See what will come. See, first come minus 60, after that plus 30 is plus 30 into 2, plus 30 into 2, after that minus 5 into 2 into 2 by 2, minus 5 into 2 into 2 by 2. Now while solving this you get the answer minus 10 kilonewton meter. minus 10 kilonewton meter. Now bending moment at D is equal to 0 because of internal hinge. Okay, because of internal hinge, bending moment at BD will be 0. Now draw the diagram. See, this is your bending moment at A will be minus 60, which is over here. This is 10 minus, this is also 0. See, this will come like this. 60, this is 10, this is also minus, this is also minus. Minus means inside the frame. Now we have done with AB part. Now see the BC part. Now consider BC part. Now draw the FBD of that part. Now draw the FBD of that part. It will come like this. See, this 5.8, this 5.8 in B going downward. To balance this point, 5.8 goes upward. Okay, now how it come like this? See, this 5.8 going up, minus 8 plus 5 plus 5, you got this value also. This value will come 7.2 kilonewton upward. You can solve by manually also. See, 5.8 minus 8 minus 8 minus 5. Okay, now you can solve directly. See, this 5.8 is going upward, this will go down, this will go down. This 8 plus 5 is nothing but 13. Then 5.8 plus 7.2 will come 30. Now this member will also get Z balance. This is 0, this is also 0. Now draw the AFD, SFD and BMD of that part. Okay, now see, there is no axial force diagram, there is no axial load, axial force, so that is axial force diagram is 0. This is B, this is C, is axial force diagram. Okay, now draw the SFD, shear force diagram. And shear force calculate over here if you want. Shear force calculation. Okay, now see, shear force B at left equal to 0, B at right equal to 5.8 kilonewton. See, shear force B at left equal to 0, shear force B at right, we are taking section over here and just seeing this side, this will come 5.84. Now we are taking section over here and taking this side also, so 5.8. Now we are taking section over here and we are seeing here, see 5.8 minus 8, this will come 2.2. Now we are taking section over here, so over here, and this was also seeing 5.8 minus 8 is nothing but minus 2.2. Now we are taking section over here and see this side. see this side, this will come, this will go upward minus 7.2. Now we are taking section over here, and see this side, this one is minus 7.2, this sign convention, this will come downward positive, this is going upward, that's why it's negative. Now we are taking section over here, and see this side, this is nothing but 0. Now draw the shear force diagram first. See 5.8 positive, come over here, 5.8, 2.2, 2.2, 7.2, 7.2. Now I'll draw all the points first. This is B, this is C. This value will be plus, outside the frame, inside the frame, inside the frame. Okay, now draw the bending moment diagram. Now bending moment calculation. Follow this sign convention, sagging positive, hogging negative. Now see, bending moment at B will be 0 because of internal hinge. Okay, now bending moment at E will become something. Bending moment at E is equal to, always see the original diagram. Please listen this word. Bending moment at E, always listen the original diagram. Don't see here, see here only, because this is not complicated, this is more complicated. See, this here come 7.2 into 3 minus 5 into 2. See, 7.2 into 3 minus 5 into 2. This will come 11.6 kilonewton meter, which is positive. Now bending moment at F equal to, now see, F equal to 7.2 into this distance 1. 7.2 into 1 is equal to 7.2 kilonewton meter. Okay, now bending moment at C is equal to 0. See, bending moment at C will be 0 because of roller support. See, now we have done with the all the calculations. In exam, if you have the time, you can calculate, or you can directly draw the diagram. Okay, now how will you draw the diagram? First A will be 0, B and C will be also 0. Now E will be 11.6, or come over here something, this will 7.2, come over here. This is your, this is all positive, away from the frame. ये bending moment diagram, shear force diagram, axial force diagram. Okay, now we have done with the all the two parts, sorry, AB and BC. See, this is our calculation, how to surface. But always remember one thing, always see the original diagram given in the question while drawing the bending moment diagram. Thanks for watching my video. I hope you understand. Thank you.